everything is in order. So yeah, please welcome Magdalena to the stage for a talk. Yeah.
There's a video. Okay, I'll just check. All right. Thanks for joining. Today's presentation is about zero gas, infinite scale, the bull case for AppChains, and how to build them. That's me, just a different hair color. But yeah, I'm doing commercials at Gelato, a bit of legal and finance. So before we start this presentation, let's look at how did Web 2 scale. So Web 2 wasn't as scalable as it is today always. And let's take a short trip down memory lane. So Web 2 started with local hosting. So if you had a website, you were running it most likely somewhere down in your basement. You had your server there, but that obviously had a lot of disadvantages. So it's neither really scalable. If you had electricity outages, your website could be down. And if you had users from the other side of the world, they could suffer from really slow loading times. So eventually, from local hosting, we went to shared hosting in the mid-90s. There were providers like GeoCities or DreamHost. I don't remember any of them, maybe you do. But what they allowed you is they provided website hosting for you. And that was already a great step, right? But it still had a lot of issues because mostly you shared all the resources and all the bandwidth with all the other websites on that server, which led to constrained scalability. And if one website had a lot of traffic, your website could suffer, even though it's completely unrelated to the original website. And it's also very inflexible and not really customizable, because usually you were bound to specific programming languages. So from there, mid-2000s, AWS, Google Cloud, there are also others. You most likely know them. We went to cloud virtual machines. So they're not physical anymore, they're virtual. And that actually led to horizontal scaling. So what you could do now is you can spin up instances, you can scale them up and down as you need them. It's very customizable. You can build very powerful applications on cloud. So what's the takeaway from this? The internet is not one huge world computer, but it's actually a web of interconnected computers. And what scaled Web 2 were actually asynchronous services. So if you were deploying servers, instances, and so on, you needed for them to communicate to each other and also to the rest of the internet. And for that, you used asynchronous communication tools like APIs or HTTP. So when looking at the evolution of Web 3, we can actually draw some parallels, and we can actually see that asynchronous cloud services are also scaling Web 3. We went from a few monolithic chains to an infinite number of virtual chains in the cloud. So similar slide. Let's try to draw some parallels to what we've just seen with Web 2 scaling. So with the emergence of Bitcoin, we had those special purpose layer 1 validator networks. And that's great, right? But if you wanted to launch a new use case, you needed a specialized blockchain, and that always required bootstrapping a validator set, which usually required a token because you need to incentivize those validators to join your network, which is costly, not that scalable, and usually also leads to security concerns, like 51% attacks and so on. So from there, we went to general purpose smart contract platforms, Ethereum, and that's already great, right? Because now you can have a lot of use cases, a lot of applications on the same smart contract platform. But still, and that's very similar to shared hosting, you still share all the resources with all the other applications on that network. So if you have an NFT drop or some meme coin or whatever, you can have your gas costs spike, and the network is just congested. So not scalable, can be expensive, and you're restricted to EVM languages. So what's the next step here? The next step is virtual blockchains on rollup as a service. What's a virtual blockchain? A virtual blockchain is a rollup. What's a rollup? It's a blockchain within a blockchain, and that blockchain is hosted off-chain by a centralized sequencer, like Gelato. So what is Gelato actually doing? Gelato allows you to deploy and maintain your own rollup and actually have a scalable environment where you don't share any resources with anyone else. It's very customizable, and you can build very powerful applications on Gelato. Let's maybe start with this one. It's a video. Can I somehow start this? Someone knows? Okay, no one knows. So actually, this is a video, and it's the Gelato platform. So if you go on the website, we have a dashboard, and you can actually configure your own rollup on there. But then let's start with this slide. So how does it look? You usually have a base layer, so you need to choose your rollup framework. You can choose Optimism, Arbitrum, Polygon, CK Sync. Those are the ones that Gelato is currently supporting. You also need to choose your data availability layer. It can be Ethereum, but that's costly, so you can also go with alternatives like Celestia, EigenLayer, or Avail. And then you have the base infrastructure, but that is not really built for powerful applications, so you need a Gelato and also a lot of third-party Web3 service providers. So Gelato is not only allowing you to deploy your rollup, but we also have a bunch of Web3 infrastructure services, smart contract automation, relaying, randomness, and so on. Then we heard from Simon, you need indexers, so the graph, you need a block explorer like Etherscan, cross-chain messaging protocols like Layer 0, oracles, a wallet, a bridge, and so on. Video not working, unfortunately. So let's go a bit more technical, but still very high level. How does the rollup design actually look like? So you have an execution layer. That's your modified version of the EVM, like Optimism, Arbitrum, Polygon. I already said that. You have a data availability layer, cheaper options like Celestia, EigenDA, and so on. And then you have your settlement layer, which is Ethereum. That's really important, because the crucial thing here is that your assets still live in smart contracts on Ethereum, and you just upload them to the rollup for high execution throughput. But so should something ever happen to your rollup, they're still secured in a smart contract on Ethereum. So let's expand a bit from there. That was the rollup design overall. But to actually build an application, you need some essential infrastructure on top of that. So you need a block explorer to actually, track, visualize all the transactions. And you also need a bridge UI or native bridge to bridge to your rollup. And that is actually what every rollup as a service provider would offer to you. This is the most minimal thing that you have or that you need. And one thing where Gelato really shines is that we package up this offering with all the crucial other services that you actually need to build powerful applications. So expanding this even a bit more, we already heard this right now with functions and oracles, but Gelato Functions, it's similar to AWS Lambda. And what you can, for example, do with oracles, you can stream price feeds to your rollup to actually build very powerful DeFi applications, like perp dexes, for example. And on the UI side, for example, if you want to build an application that has a great user experience, where you can use, for example, Google sign-in, and you don't want your users to deal with MetaMask or setting gas prices and so on, you can use Gelato Relay, which provides you with an account-abstracted way for users to interact with your blockchain, and they don't have to deal with any low-level complexities anymore. Then again, indexers, so you can visualize your data. We talked about the rest, I think, here. Yeah, one important thing, interoperability is very important, because you don't want to have your rollup be very isolated. You want it to be able to talk to other chains, to tap into other user bases, and so on and so forth. And for that, you need liquidity providers and cross-chain messaging protocols to actually make that happen. Yeah, horizontal scaling, a buzzword on there, shared sequencing. So the example I'm doing is a bit flawed, but like imagine you have 3 different rollups. Let's assume you're building a game, and you have 3 different rollups because for whatever reason you want to segment your user bases by country. So you have one in the US, one in Asia, one in Europe, for example. You have 3 different rollups for that. And they all talk to each other, but they do it in an asynchronous way, right? And if you want to have a really great in-game user experience, what you want to achieve is that you have those rollups talk to each other in a synchronous and atomic way. And for that, you would need shared sequencing. And what we're doing at Gelato, we're currently researching this topic together with Espresso, who's a shared sequencer. But yeah, this is still in research phase and not live yet. And what's the takeaway here? The takeaway here, as with Web 2, is that Ethereum is not one huge world computer, but it's a Web 3 of interconnected rollups, all talking to each other, built on Gelato. Yeah, if you want to build a rollup, you can do all of that very easily on our platform. These are projects that are customers of ours, so we also have infrastructure services. We work together with more than 400 projects. Most of these projects on there are using our infrastructure services from, PancakeSwap, SushiSwap, Optimism, Safe, Zora, and so on and so forth. And yeah, so if you're looking for a job, we're also currently hiring. We have an office in Zug. You can work remotely, check out our jobs, come talk to me. Yeah, that's pretty much it. Thank you.
Hello. Thank you so much. Any questions? 2 questions. You have 1 mic coming that way.
So we have Web3 infrastructure services and we have rollups. Business model is pretty similar. So for rollups, it's a monthly subscription fee and sequencer revenue. And for middleware services, it's also a subscription fee that you pay.
We have another question. Go ahead.
Yeah. Hi. 2 questions. First one is really stupid, but let's say, for example, you connect MetaMask. Do you have to select Gelato as a separate network, or are you going to connect to Optimism to kind of, get involved in the ecosystem? Like, how is that going to work from a user interface side? And the second question is I wanted to understand a bit more how you differentiate yourself versus the likes of Dimension or Altlayer that obviously have also come up with this kind of similar service.
Yeah, so the first question, no, you would not connect to Gelato as a network. So I'm not sure if you're talking middleware rollup. No, I guess rollup. So if we are launching a rollup, and for example, we launched one for Rhea, for Tangible, for Asta, we're launching a rollup for them, and it would be Asta, it would be the rollup you're connecting to, but you would not connect to Gelato. Would that answer the first part of the question? And the second part of the question, that was?
Yeah, I just wanted to understand a bit more how it differentiates
yeah. Yeah, I think what I showed, this one slide where I showed this is the most basic design of a rollup. So if you're looking for rollup as a service provider, this is usually what you get, right? That's the bare minimum chain, and you get a block explorer on top, but that's pretty much it. And I think where Gelato really shines and is different from all other RaaS providers is that we provide this comprehensive infrastructure package. We package it all together for you, and you get all those services and all the infrastructure deployed from day one on your rollup to really be able to build powerful applications.
Thank you. Any other questions? All good? I think Gelato has one of the best names products because I feel like eating with Gelato after your talk. Thank you so much.
Welcome.